Hello learners, today we will be discussing about temperature regime. Intergovernmental Panel on Climate Change in its assessment reports stated that warming of the climate system is unequivocal, and since 1950s many of the observed changes are unprecedented over decades to millennia. The atmosphere and oceans have warmed, the amounts of snow and ice have diminished, sea level has risen, and the concentration of greenhouse gases have increased. The human activities are estimated to have caused approximately 1 degree centigrade of global warming above pre-industrial levels, with a likely range of 0.8 degree centigrade to 1.2 degree centigrade. Global warming is likely to reach 1.5 degree centigrade between 2030 and 2052 if it continues to increase at the current rate. When we consider the 100-year period from 1906 to 2005, the mean increase in temperature was 0.07 degrees centigrade per decade. But the mean increase for the last 50 years, if you see from 1956 to 2005, has been nearly twice, that is around 0.13 degrees centigrade per decade, showing that the rate at which the earth is warming has increased tremendously. So the global average surface temperature for the decade, as I said, it is in the last decade it is 0.87 degrees centigrade. It is it's a very major increase, and definitely it calls for action. The extremely cold days, cold nights, and frost have become less common, while hotter days, hot nights, and heat waves have become more frequent. Surface warming is not uniform across the globe, nor is it constant over the seasons. At different places, at different times, warming is affected by strong regional variation, which are difficult to predict. Even they can magnify or moderate the different elements of climate, adding to the uncertainty of predicting future scenarios. Nevertheless, some trends have been noticed, and this is important for us to understand. Just because that once you understand the trends, it's very easy for us to predict the future, and also we can have our adaptation strategies appropriately. So let us see first the trends in temperature. The temperature records are present from 1850 onwards. Before that we don't have the instrumental records. Since 1850 we have temperature records. In fact, they have been recorded at numerous land stations, and by using the techniques like weather balloons, even instruments can be on the ship also. That provides us a fairly comprehensive idea of the increase in temperature across the globe. When you look at the globally averaged combined land and ocean surface temperature, as I stated earlier, so the total increase between the period between 1850 to 1900 and the 2003 to 2012 period, if you see the trend, the total increase is about 0.7 degrees centigrade. In fact, to an extent, the entire globe is experiencing surface level warming. It is stated that globally, since the second half of the 20th century, since the 1950s, if you see, the troposphere has warmed. The period between 2001 to 2009, that is in the present century, is 0.1 degree centigrade warmer than the 1991 to 2000, just the previous decade. So the 1990s have been the warmest complete decade, with the warmest year being 1998. In 1998, it's a very unique, the year is very unique for a simple reason is that, the effects like El Nino was noticed, was observed, and in that particular year, if you see, the temperature was around 0.5 degrees centigrade above the 1961 to 90 mean. It's a tremendous increase. When you look at the temperature, the pattern across the globe, particularly the land masses, ocean, there are a lot of variations there. Since 1979, the land temperatures have increased about twice as fast as the ocean temperatures. Further, the land masses are unequally distributed in the two hemispheres, in the northern and southern hemispheres. High latitudes are warming at a higher rate than low latitudes. It is also reported that occurrence of the extreme weather events has changed since 1950. It is very likely that the number of cold days and nights has decreased and the number of warm days and nights has increased on the global scale. The frequency of heat waves has increased in large parts of Europe, Asia and Australia. There are likely more land regions where the number of heavy precipitation events, in extreme events, has increased than where it has decreased. The frequency, or in other words the intensity of heavy precipitation, extreme events particularly, has slightly increased in the North America and Europe. So, the effects of heat wave are felt more severely in the cities. The urban areas, they are very warm round the clock due to urban hinterland effect and due to the urbanization and other industrial activities. The heat waves have claimed more lives over the past 15 years than all other extreme weather events put together. So, the heat waves are a significant phenomenon. In Europe, the record heat wave during the year 2003 August caused the death of 35,000 people. Of course, France suffered the most losses with at least 14,000 deaths attributed to the heat waves. The winter months have warmed faster than the summer months, and the greatest warming is expected during the winter over northern North America and North Central Asia. The day and night time temperatures have increased at the same rate, though the trends vary from one region to another. There is a lot of spatial variations. The warming is expected to be much more in the continents, as I said earlier, in the higher northern latitudes during winters, and least over the southern ocean and parts of North Atlantic Ocean. Most of the North America, all of Africa, Europe, North and Central Asia, and most of Central and South America are likely to warm more than the global average. In fact, the projections suggest that warming will be close to the global average in South Asia, Australia, New Zealand and Southern South America. The IPCC report, the recent report, states that the upper ocean 0 to 700 meter warmed from 1971 to 2010. A large part of the heat absorbed goes into the evaporating the water, while the rest warms up the water, ocean water. Further, the water can move vertically, so the heat is not restricted to the air-water interface. It is dissipated throughout because there is a lot of vertical movement also exists in the water system, ocean water system. The observations since 1961 show that the average ocean temperature has increased to depths of at least 3,000 meters, 3 kilometers. Nevertheless, globally the ocean warming is observed to be largest near the surface and upper 75 meters. That's what the report states. 60% of the net energy increase in the climate system is stored in the upper ocean body between 0 to 700 meters, and the ocean below 700 meters stores about 30%. So, ocean is a very, very important ecosystem which moderates the climatic system. The average temperatures in the Arctic region have increased at almost twice the global rate in the past 100 years. This is partly due to the positive feedback effect, we call it as the ice albedo effect. Temperatures at the top of the permafrost layer have increased since the 1980s in the Arctic region by up to 3 degrees centigrade, which is twice as fast as global average temperatures. In fact, this is linked to the changes in the snow cover. The ground absorbs about 4 to 6 times more of the sun's energy when it lacks snow cover. So, the summer ice in the Arctic Ocean is decreasing by 7.4% per decade, and definitely the permafrost is on the retreat. It's a very important aspect to be noted. since because the climate warming and the global warming can cause a lot of harm to the in the permafrost region, and that can have a deep impact on the ocean ecosystem. I mean the extreme events and also increase in the sea level. So the maximum area covered by the seasonally frozen ground has decreased by about 7% in the northern hemisphere since the 1900, since in the last century, and the snow is melting very fast in the even during early spring and later. So there are a lot of anomalies. If you look at it, the parts of Antarctic region, and a lot of anomalies are there, spatial variations are there. Nevertheless, the impact of increase in temperature on the snow cover and the permafrost region is very, very significant. During the past few decades, if you see the Greenland, I am talking about the Greenland and the Antarctic ice sheets, losing mass. The glaciers across the globe to an extent decrease in size, and incidentally, if you see the Arctic sea ice and also the northern hemisphere spring snow cover was observed to decrease markedly, or in other words significantly. The sea ice is projected to shrink in both the Arctic region and also in the Antarctic region. So according to the most pessimistic scenario, the Arctic late summer sea ice may disappear almost entirely by the later half of the 21st century. It is in fact a pessimistic scenario. Now let us see about the trends in the precipitation. Warm air can hold more moisture. It's a fact. The water holding capacity of the atmosphere increases by about 7% for every 1 degree centigrade rise in the temperature. This additional water vapor drives the hydrological cycle harder, much harder, increasing the amount, frequency and intensity of precipitation. Global warming, whether it is a land on the ocean system, affects precipitation in many ways. It changes the wind patterns and even the ocean currents. So a lot of changes can happen because of global warming. And that can have a drastic effect on the precipitation pattern, the frequency, the intensity and other related extreme events. Predicting future changes in the precipitation is very difficult because it is influenced by many factors. Unlike the global temperature rise, the regional variation in precipitation trends are very large and have a strong influence. I mean the regional, the elements, the climatic elements can have a lot of influence on the precipitation pattern. Some regions show a very rising trend while some show a downward trend. When you look at the global level, in the last 3 decades, the total amount of rainfall has changed very little, but in the tropics, where nearly 2/3 of all rainfall occurs, there has been an increase of 5%, and most of it, it's over the oceans. Precipitation over land has decreased slightly. The tropics have seen maximum changes in the precipitation. If you look at the last 27-year long global record of rainfall from satellite and ground based instruments, scientists have found that the years of heaviest rain in the tropics between 1979 and 2005 have been mostly occurred since 2001. So a lot of changes are happening in this present century. The precipitation averaged over the mid-latitude land areas of the northern hemisphere has increased since 1901. Rainfall has increased in the eastern parts of North and South America and northern and central Asia, but decreased in the Sahel region, in the fringes of Sahara Desert, the Mediterranean region, the southern Africa and also parts of southern Asia. So the drying effect of higher temperature and much lesser rain has increased the drought conditions. The temperature regime in these areas also is to be noted because because of these conditions, very high temperature and less rainfall, that can have a different effect on the ecosystems, on the terrestrial ecosystems, on the living organisms. There even the vegetation pattern, everything will be changing because of the conditions, whether it's a changing temperature or else the precipitation. And nevertheless, both are interrelated. The frequency of heavy precipitation events has also increased in some parts of the globe. Increased amounts of water vapor leads to more number of wet days in some part of the world. If you see the parts of northern Europe have witnessed a 50% increase in the rainfall between the 1900 and 2005, but there is not much change in the total precipitation since increase in water vapor is only in the range of 4 to 5%. Heavy rain events, heavy rainfall may have long dry spells in between. That is the most tricky thing because a lot of variability exists in the climate system. This increases the risk of both droughts and floods because you have long dry spells definitely lead to drought conditions, and this heavy rainfall, the intensity if it is more, definitely that can lead to flood. Coming to the oceans, with respect to the precipitation pattern, the regions of peak sea surface temperature will get naturally better because the sea surface temperature is correlated with the precipitation pattern. And if you look at the maximum temperature rise in the Pacific is along the broad band at the equator. So that is the point has to be observed actually. Warming in the western Indian Ocean. Western part of Indian Ocean is amplified, in fact reaching around 1.5 degrees centigrade, while in the eastern Indian Ocean it's it's around 0.5 degrees centigrade. It's kind of a dampening effect. This can dramatically shift the rainfall over the eastern Africa, India and Southeast Asia. In a way, what I am trying to say is that the climate change can have an impact on the monsoon system, and because of the effect on the monsoon system, the rainfall, the pattern, everything will be changing in this particular region. Definitely the Eastern Africa, India and Southeast Asia. I am talking about the Indian monsoon system. The monsoons in Asia have gained in strength over the past few decades, but due to all these reasons, if their behavior is changing, making them more variable, difficult to predict. A lot of uncertainty has arisen because of climate change and variability. Rains started occurring much earlier, or in other words it's very shorter and more intense and high frequency. I mean, when I say intense burst, and so at times in the winter monsoon is also abating. The changes in the type of precipitation have been observed in many places, but especially in the middle and high latitudes in the northern hemisphere. Definitely, because in that particular northern hemisphere, the land masses are much more than the ocean system. More precipitation now falls as rainfall than snow in the northern region as spring sets in earlier. This is a very important observation because when I say snowfall is decreasing, and that can have an impact on the snow cover and the permafrost also. The total snow cover, if you see on an average, decreased in both hemispheres. So now we have seen the trends in the temperature and precipitation also. Now let us see the trends in the sea level rise. Definitely, because both the temperature and the precipitation can have an effect on the sea level also. The rate of sea level rise since the middle of 19th century has been much higher than the mean rate during the previous 2 millennia. Sea level has increased at an average rate of about 1.8 mm per year during the years between 1961 to 2003. The rise in sea level during 1993 to 2003 was at an average rate of 3.1 mm per year. In fact, over the period between 1901 to 2010, the global sea level has increased by 0.19 meters, that is around 19 centimeter. It's a tremendous increase. It is expected that a further rise in the sea level will occur in all climate scenarios. If we have a lot of greenhouse gas scenarios, all climate scenarios, whether we consider low, medium or high rates of greenhouse gas emissions. The increase in sea level is mainly due to two factors. First important factor is the thermal expansion of seawater and the melting of the land ice sheets, that also can increase the volume of water in the ocean. As global temperatures rise, seawater also warms up, its volume increases and thereby the sea level rise. Even if we do not consider melting water from the ice sheets, huge ice masses, it is estimated that sea level will rise by 18 to 38 centimeter for low greenhouse gas emission scenario and 26 to 59 centimeter for high emission scenario due to thermal expansion alone. Sea level rise also varies in different parts of the world due to ocean circulation and wind pressure pattern. The second factor behind the sea level rise is the melting of ice sheets in the Arctic region. Average Arctic temperature have increased, as I said earlier, at almost twice the global average in the past 100 years, and most Arctic glaciers are rapidly losing mass as the rate of snowfall is less. It is reducing, that's what I have stated earlier. So this is a second important reason. So this we have to take into account. When you look at the Greenland ice sheet, it's the second largest body of the ocean on the planet. Parts of it, it's a top layer, melts during summer. In the last 30 years, there has been a 16% increase in the area prone to summer melting, and 1/3 of ice sheet is now affected severely. Ice loss from its margins has doubled over the last decade in spite of snowfall in the interiors. A continued rise in the global temperatures will increase the rate of its melting as well. Antarctic ice sheet is much bigger than the Greenland ice sheet, and it is when you look at the loss, it has lost about 13,500 square kilometers of its outlying ice shelves over the last 50 years. But the overall Antarctic sea ice shows no significant trend as warming is less in the southern hemisphere. There is much uncertainty over the magnitude and speed at which ice sheets will melt, but it is acknowledged that they react quicker to increases in temperature than experts thought just a few years ago. It is estimated that for a relatively low greenhouse gas emission scenario with just 2 degrees centigrade warming over the 21st century, the present century, sea level will likely to rise by more than 1 meter. When the full set of emission scenarios and estimated uncertainties are considered, the sea level may rise by anywhere between 75 centimeter to 1.9 meters by the year 2100. When you look at the sea level rise, definitely we need to understand that what kind of impact it can have on the coastal locations. The densely populated mega deltas, whether it is a Ganges delta, Mekong, and Nile river delta, will be directly affected because of the increase in the sea level. Particularly the low-lying coastal cities and villages will be flooded. Within South Asia, Bangladesh would experience the largest percentage share of land area being impacted because of increase in the sea level. With the 1 meter increase in the sea level, about 0.8% of the total population of Bangladesh and the Sri Lanka would be displaced, and some island nations also like Maldives, which is in the Indian Ocean, would be submerged. So when you look at these aspects, a lot of steps need to be taken to curtail greenhouse gas emissions, and that can have definitely a positive effect as far as the management is concerned. When you look at the increase in temperature and increase in precipitation, one related phenomenon is the cyclones. In fact, these all are natural weather events: rainfall, hurricanes, tornadoes. These all are natural events. The Earth's rising temperature can impact these weather events, by pushing them to the extremes. That is the most important point, and because that is very much part of the climate variability. Weather events of all kinds may become stronger and more intense in the long run. That's a point that need to be taken. In fact, if you look at the hurricane, it's an intense tropical storm formed over the warm tropical ocean during the periods when the local sea surface SST sea surface temperature are above 27 degrees centigrade, and wind speeds are more than 74 miles per R. So in that condition we call that as a hurricane. It's a severe tropical storm, and it is also called as a typhoon or cyclone in different parts of the world. The hurricane activity, if you look at it, it is, the frequency, the intensity, it's fast increasing because of climate change. The Western Pacific Basin is the most active, and the North Indian Ocean, if you see, it is the least active. An average of 86 tropical cyclones of tropical storm intensity form annually worldwide, with 47 reaching the strength of an typhoon or a hurricane, and 20 becoming intense tropical cyclones. When you look, you analyze the global hurricane data, there is no significant increase in the number of tropical storms and hurricanes worldwide. Only one region, the North Atlantic, has shown a statistically significant increase in the number of cyclones and cyclone days during the past decade. The hurricanes and typhoons have become stronger and longer lasting over the past 30 years. It has been suggested that the increase in the hurricane activity is linked to the rise in sea surface temperature, but we need to take into account more data and a better understanding of cyclones to come to a definite conclusion. To sum up, we have discussed about the trends in temperature, precipitation and sea level rise. Thank you.